and another course begins here in the Carroll family classroom slash recording studio. So you can see, I've got my whiteboard back here, got a Pikachu to keep me in line. So, hopefully we got everything we need. Although I have to say, as a mathematics teacher, all of this blank white space on this board, it's kind of giving me the heebie-jeebies. Ah, that's better. So we typically start off a calculus course with sort of a brief refresher on stuff that you should be familiar with from a pre-calculus course and your other mathematical background. So first thing I wanted to mention here are sort of some properties of exponents that we're going to end up playing around with fairly often as the course rolls on. So fairly usual stuff again. Hopefully nothing here is really catching you off guard. So I'm trying to stay off to the side for a moment while you take a moment. I don't know why, because you can just press pause. But anywho, one thing I do want to point out, do note that this, raising something to 0th power, it does give us 1 in a world where I had more time. I'd sort of walk through all this because I kind of enjoy that sort of thing. But yeah, so raising something to 0th power would give you 1 unless x is 0. We don't try to define what 0 to the 0th power means. Just that way lies madness. Stay away. But yeah, sort of our general ways of combining exponents. Multiplying, again, we have to have the same base here. These are both x. Note if this were a y, we can't really do anything to combine them. So x to the a plus b, division becomes x to the a minus b. Note thing in the bottom, the denominator of the fraction, that's the thing we're subtracting away. Raising, an exponential expression like this to another power, we multiply the powers together. We've already talked about x to the 0 being 1. Negative exponents, you can, get rid of the negative by sort of flipping into the denominator of the expression. You got that. And fractional exponents, at the end, they represent sort of root expression. So again, like your denominator here is, the root. So this is the bth root of x raised to the a power. So we generally would not write a 2 here for what we call a square root. If you don't see, a 2, or if you don't see any number there, assume it's a square root or a second root. So there's our properties of exponents. Let's play around with them for a bit, but I'm going to need to clear some space. All right, let's fill this up. Like I said, the white space bothers me. So let's see if we had something like this. X squared, y cubed, and we'll square that whole puppy, and then we'll divide that by x, y to the power of the 10th. So, all right. So if we wanted to what we call simplify this expression down, so we don't have any extraneous stuff hovering around in here, usual order of operations says I need to resolve this square here first because it's on, as we say, we got something inside parentheses, then we do exponents. So each of these things is individually squared. You can kind of write it out if you want to. So you'd have x squared times x squared, or x squared squared. In either case, that would be x to the 4th. Y cubed squared would give me y to the 6th, because 3 times 2 is 6. Then we have an x down below, and we've got this y to the 10th, and I find myself regretting what I did. But anyway, so now we can use those division properties to sort of gather stuff up here. So we have this, if it doesn't have an exponent, remember we can sort of assume there's a 1 right here. So we have x to the 4th divided by x to the 1st. X to the 4 minus 1 gives me x to the 3rd, or x cubed. We have y to the 6th, and then we have a y to the 10th down below. So if you use the properties, I'm going to change my plan here mid-calculation. So we had x cubed. X to the 6 minus 10 gives me y to the negative 4. So that's one way you could write this. Some folks kind of think it's bad form to leave negative exponents hovering around. It doesn't bother me all that much in the grand scheme of things, but just in case you're used to that. So now we're going to use that other exponent property, flip that guy down into the denominator, and get rid of the minus sign on the exponent. So it would just look like x cubed divided by y to the fourth, and that was the part I regret. My handwriting is such that the y and the 4 kind of look alike, but y to the fourth. So, all right, there's one example. So there will be some more in the lab assignment and the homework exercises where you can play around with this some more, but again, this should not be new territory for you. This is designed as recap. So let me clear this off real quick, and then we'll take a look at another example. Okay, so sort of working in the opposite direction from what our properties of exponents were saying here. What if you were given a root expression like this and you needed to convert it into a fractional exponent? So keep in mind our setup here. Well, our variable doesn't change. Remember, it's whatever the power on this thing under the radical is over the type of root. So that would be x to the 7 thirds. Similarly, if you had just had, I don't know, x to the 9th. Oh, yeah. So we have the square root of x to the 9th right there. That's x to the 9 over, well, we don't have a number here. What did I say? If we don't have a number here, it is assumed to be 2 for this one instance. I know it feels like this, like kind of like exception that proves the rule thing, because very often we think of this as a, if there's no number there, we can assume it's a 1. Like I said in that previous example, that x by itself was x to the first. For roots, it's like the one weird edge case. So do keep that in mind. And you could be asked to interpret these like the other way around. So if we had, x to the, I don't know, 10 sevenths. So now that would come back. The numerator in our fractional exponent lives with the x underneath the radical. The denominator of our fractional exponent is the level of root we're dealing with, the 7th root there. So, all right. So we dealt with our properties of exponents. We talked a bit about fractional exponents. So hopefully you'll feel kind of comfortable with that part. So let's take a look at something else. So in this example, we don't really need those properties of exponents quite so much, like just a little bit. But the bigger thing I wanted to come back to is what we have to do if we're multiplying together what you would call a binomial expression, where we have two terms linked with an addition or a subtraction symbol. So I've mentioned this. I described, as you can see, the header, our friend FOIL. There are a slew of different methods out there. I'm fine with whatever you've used in the past. Some students like to draw like grids. I learned from my buddy the FOIL algorithm way back in the midst of time, and I'm way too old to go changing gears. So FOIL is an acronym, stands for first, outer, inner, last. So that way you sort of make sure you cover all the possible things that you need to multiply together. So I grab my first two terms here. 2x times x. That would be 2x squared. Again, that's like the baby property of exponent bit here, because 1 plus 1 is 2. Then we do the outer. Those are the two guys on the outside. The 2x times -7. That gives me minus 14x. Then the inner plus 2x. And then we have the last. 2 times -7 is -14. And you've technically done the what I would call distributing, but it's kind of ugly to leave these two terms like this right here. So I would prefer for them to be gathered up like so. Minus 14x plus 2x. That gives me minus 12x minus 14. So we have 2x squared minus 12x minus 14. If you were needing to go in the opposite direction, which we'll actually be doing in the next video, you might have to start from this and then kind of work your way backwards. Again, factoring is something I kind of take for granted that you have seen in the past. I'm happy to help you out if you've got questions on it, but in the interest of moving things along, I want to take a look at some other stuff. So that's it for this video. In the next one, we're going to take a look at doing a little bit more with something like this, a little algebra for dealing with things of this nature. If you're wanting to find particular, if you set this equal to say 0, where does that happen? So that's next time.